Hi, pre-calc students. Is going to be trig day 2. After some good practice with evaluating some trig functions, we're now going to work backwards. So if you think about what we've done up until this point, mostly we've been evaluating things like sine, cosine, and tangent when given an angle in this location, right? We could do sine of 30 and we can do sine of 120 degrees and things like that. So now we kind of want to work backwards from here and think about what angles could I plug in here that give me the ratio of 1/2 for the sine function. Or similarly over here, we're going to figure out what ratios for the cosine function would return the answer -1 over radical 2. These answers should look pretty familiar from what we've done with evaluating over the past few days, but now we want to think about a process that would allow us to work backwards. So to get started, we are finding just the angles from 0 to 360 that satisfy these conditions. Notice how 0 is included, but 360 is not. That kind of makes a difference because 0 and 360 we kind of think about as being in the same location, right? If we think about the unit circle. So we don't typically include both, but we'll see if that even comes up in any of our questions here. So to get started, here's what the process is going to look like. First thing we have to think about is that we will have multiple answers. When you have that sine theta equals 1/2, what I want you to do for each of these questions is do a little ASTC, which maybe I've already told you at this point. A good way to remember this is you are in my all-star trig class. And what this means is it tells you which quadrants certain trig functions are positive and negative in. If I'm looking for where sine is a positive ratio, we're looking at quadrant 1 and quadrant 2. Everything's positive in 1. That's what A stands for. They're all positive there. The S in quadrant 2 means sine is positive there. It's the only positive function. So from there, I'm going to go ahead and draw 2 triangles. One of them is going to be in quadrant 1, and the other is in quadrant 2. What I'm trying to figure out is what is this reference angle theta? Because once I figure out what theta is, I can then start answering the question, what values of theta produce that ratio of 1/2? Well, the other thing we have to remember about sine is the ratio of opposite over hypotenuse. If I can squeeze that all in there. So from the angle theta, we want to make the opposite side a 1 and the hypotenuse a 2. You can do the same thing in this triangle over here. In quadrant 2, you can make the opposite side a 1, the hypotenuse a 2. And I'm hoping what stands out to you is that the missing leg is radical 3 to complete the pattern. Technically, on the left side here, you would put a negative radical 3, but that's actually not the most important piece here. What I need to do to come up with my answers is we're going to get a quadrant 1 answer, and we're going to get a quadrant 2 answer. So the nice thing about quadrant 1 is we have to think about what's that angle across from 1 in this special triangle. And it turns out that that angle is 30 degrees. And if you're in quadrant 1, you don't have to do any additional work once you figure out what the reference angle is. Your reference angle is your answer. Quadrant 2, you have to do just a little bit more work because the angle that we're actually looking for is this angle right here that brought me into quadrant 2. Now, the reference angle is the same. The reference angle is 30, but how am I going to figure out that green part? Well, I think you guys could probably visualize this pretty easily. We know halfway around is 180. So if you do 180 minus the reference of 30, that gives you the other answer of 150 degrees. So there are 2 angles, 2 values of theta here that would satisfy this equation. We would have theta equals 30 degrees and theta also equals 150. Okay, so I may not write out, kind of the quadrant business every time, but certainly would encourage you to do so if that helps. Let's use a really similar logic moving across the cos theta equals -1 over radical 2. The first thing you have to determine is what quadrants are we in? Okay, so if we think about cosine and where cosine is specifically negative, everything's positive in 1, so we're not there. Would cos be negative in quadrant 2? Absolutely. Cos is also negative in quadrant 3, but the C in quadrant 4 means that cosine is positive in quadrant 4, so we can cross that one off. So we need 2 triangles in this one as well. We need a triangle in quadrant 2, and we need another triangle in quadrant 3. So let's go ahead and set that up. Remember that when you draw your triangles, they have to look like part of a bow tie. They're always going to connect to the x-axis when you draw the right angle in. Cosine as a ratio is adjacent over hypotenuse, so we want to make sure we label sides appropriately here. These are the 2 thetas that I'm trying to find. The adjacent side to that reference angle theta is actually the side that's shared between these two triangles. So squeeze that -1 in there if you can. And we know that the hypotenuse would be radical 2 in both those locations. Now, when you have a radical 2 on the hypotenuse as opposed to just a whole number 2, we know that the pattern's a little bit different, that these legs would be 1. It's the pattern 1, 1, radical 2, because we're working with a different reference angle this time. It's not a reference of 30. Hopefully you can see that the reference angle for each of these is 45 degrees. Now, 45 degrees happens to not be one of the answers here for theta, because 45 degrees would be an angle that's in quadrant 1. So once I find the reference angle, what's that little angle right here? In quadrant 2, we just did that a second ago. So that would be 180 minus the reference of 45. So that's 135 degrees. And then I want you to think about, how do I get a quadrant 3 angle in general? Here's the angle sketched in quadrant 3. So how did I get there? Well, I went halfway around, that's 180, and then I added on the reference angle. So in general, for quadrant 3, you're going to take 180 and add the reference of 45. And that gets you to an angle of 225 degrees. So therefore, the two values of theta that satisfy the equation cos theta equals -1 over radical 2 are 135 and 225. Okay, now that we've seen a few, let's go ahead and maybe pick up the pace a little bit here. So if we try tan theta equals radical 3, let's bring some tan into the mix. Tan theta equals the square root of 3. First and foremost, I might encourage you to write that as radical 3 over 1. Write it as a fraction, so we can think of tan as being opposite over adjacent. So before I think about labeling those sides of the triangle, let's think about tangent, all-star trig class. Where is tangent a positive ratio? Tan is positive in quadrants 1 and 3. They're all positive in 1. Big capital T means that's where tan is positive. So let's draw two triangles in each of those quadrants. And then once you draw the triangles, here's your reference angle theta that we're trying to find. We want to label opposite the reference as radical 3. And then the adjacent side gets the 1. Okay. So in quadrant 3, again, technically these would be negatives because a negative over a negative is why this becomes positive. But if you forget those negatives, you're still going to, at least I hope, get the right answer. This is the pattern 1, radical 3, and 2 would be on the hypotenuse. Let's talk about what the reference angle is. The angle that's across from a radical 3 in this special triangle is always 60 degrees. So we need to take that reference angle, apply it in quadrant 1, and also apply it in quadrant 3. Quadrant 1 is easy, right? Quadrant 1 is 60. That's it. And if we saw what we did in quadrant 3, just in the last example, you're going to take half a circle, 180, and then add on that reference angle of 60. So 180 plus 60 is 240. Thus, the two answers that satisfy this equation are 60 degrees and 240 degrees. You can see how important your knowledge of special right triangles are in order to be successful here. Okay, let's try something with a reciprocal function. Cosecant theta, I'll say equals -2. Now, whenever you don't have a fraction, it might be nice to write this as a fraction, put it as -2 over 1. And when I think about labeling sides, you got to remember that cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, the reciprocal would be hypotenuse over opposite. So that's how I'm going to label those. And you have to be, I think, just think a little extra carefully about that when you go to do some labels here. Okay, let's talk about where I'm going to even be, though. If it's the reciprocal of sine, then it's going to be negative in the same places where sine is negative. Sine is negative in the bottom two quadrants. It's positive in 1. It's also positive in 2. So cosecant would be negative in quadrants 3 and 4. So let's draw some triangles in those two quadrants. Okay, there are my reference angles that we want to try and find. We're going to label hypotenuse as 2 and the opposite as 1. Now, I realize that the negative really seems like it should go on the hypotenuse. I just never label the hypotenuse as negative as just a rule of thumb. It makes things really confusing later on. I could just as easily have put the negative with the 1 on the bottom, and that's really where we would see that label. Okay, we've seen this triangle once or twice. If it's 1 and 2, then the missing side's radical 3. So we can fill in those other missing legs. And we also know in this case that the reference angle is across from a 1, that's 30 degrees. 30 degrees. All right, we have to apply that to quadrant 3 and then quadrant 4. So in quadrant 3, we're going to take 180 and add the 30 because we've done that now a few times. So that's going to be 210. But what about quadrant 4? We haven't seen anything in quadrant 4 yet. And the rule will always be the same. There's the angle sketched in quadrant 4. If you think about where that reference angle is, adding on that reference angle would complete a full circle, a full 360. So in quadrant 4, if you do 360 and subtract out that little reference angle of 30, that will always get you your answer in quadrant 4. So the two answers for theta in this one are 210 and 330. Okay. So if we think about maybe just one more example, let's go ahead and try one more. We'll do sine theta equals 1 is the last one we'll look at. And again, if I just write sine theta equals 1, maybe we want to put a 1 over 1. And if we think about where sine is positive, we've done that a few times. Sine's positive in quadrants 1 and 2. So sine is opposite over hypotenuse, so I can label those, right? Opposite over hypotenuse. And as soon as you start labeling this picture, and I'm kind of going through this quickly, there's something very wrong about this picture, isn't there? Is there ever a time where the hypotenuse is the same length as the opposite side? Isn't that going to be really bad news in a right triangle that the hypotenuse is equal to another length? It's just never going to happen. So what I'll tell you is for sine theta equals 1, there is a solution, but it doesn't come from drawing triangles. If you have sine theta equals 1, or for the same matter, cosine theta equals 1, it's going to be a question that involves the unit circle. Remember that unit circle business? Oops. No, did I make that a star? All right, unit circle. Here it is. Here are the 4 points on the unit circle. They are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Those are the 4 points on the unit circle. Well, I want to know what angle gives me 1 when I do sine of that angle. And what you have to remember is that on the unit circle, xy corresponds with cos theta, sine theta. So remember, sine theta goes with a y value. I want to know sine of what angle, the angle theta, is going to give me a y value of 1. So we're looking for when is the y value equal to 1. And there's only one time when that happens. The y value is 1 right up here. No other point on the outside will the y value equal 1. How many degrees is that? Well, it's 90 degrees. So the answer to this question is theta equals 90, but it doesn't come from drawing a triangle because the triangles simply don't make sense. So for this example, when you see something like this, you got to use the unit circle. It's going to take a little while to get used to because I think we definitely, by the end of that 4th example, I'm hoping you're getting the sense of how we do it with those nice reference angles drawing the triangles, but unit circle takes a little while to figure out the patterns and how to recognize when we should be using the unit circle. Okay, the last thing we're going to do today is a lot of the same stuff. We're still going to find all values of theta. But I'm going to change up how we're defining theta. We're going to define theta this time to be an angle from 0 to 2 pi. So it's the same exact process that we were just looking at. However, my answers in the end have to be in radians. Okay. So we're going to try our best to kind of keep things in radians. We'll see how well we do with that. Okay. So let's try cos theta equals radical 3 over 2. Cos we know is adjacent over hypotenuse. And I know cos is positive in quadrants 1 and 4. So you're going to start this one by drawing a triangle in quadrant 1 and quadrant 4. If it's adjacent over hypotenuse, we know that we get radical 3 on that adjacent side and that the hypotenuses are 2. The opposite side in this triangle will be 1 in both those cases. But what I'm looking for now is what is the reference angle? What goes across from 1? Well, moments ago, we said that theta would have been 30 degrees. Well, now, since this is a common radian value that I want you to really just know, I know that now theta is pi over 6 in radians. Now, the way you can come up with that so quickly is if you know pi is 180 degrees, pi radians. Well, 30 is 180 over 6. Okay. So we want to use pi over 6 as one of our answers. In quadrant 1, that is the answer. There's nothing to do. Pi over 6 is the answer. How do we get to quadrant 4? Well, I think the easiest way to do it is to think about this angle right here. Halfway around we know is pi, which is, by the way, 6 pi over 6. We're working with a denominator of 6 here. Full circle is 2 pi. If I put a 6 on the bottom, I got to multiply the top by 6, which I can really quickly fix by making that a 12 pi over 6. So we're not quite to 12 pi over 6, are we? We're 1 pi over 6 before that. That's what that angle is right there, pi over 6. So in quadrant 4, what's my answer? 11 pi over 6. Now, if it's really challenging for you at first to get your answers in radians, put them in degrees, which are 30 and 330, and then do the process of multiplying by pi over 180. That's going to reduce to 11 pi over 6. Could you do that? Yes. By the end of this unit, should you be able to convert these quickly over to radians? I would think so. Okay, let's move on to dealing with, let's bring in some cotangent. Cotangent theta equals, let's do radical 3 over 3. Okay. When you see something like radical 3 over 3, what I want you to recognize is that prior to becoming radical 3 over 3, it most likely was this ratio right here, 1 over radical 3. And that's going to really help because I'm telling you right now, we don't have a triangle who has a side length of 3. If you think about the two special triangles, none of them have a 3 on one of the sides. And the reason why we get this ratio here then is because it used to look like this, 1 over radical 3, and then it got rationalized. So to make my job easier for number 2, I'm going to write it as 1 over radical 3. Cotangent is the reciprocal of tangent. So this is adjacent over opposite, because tan is opposite over adjacent. And then we have to think about where is cotangent positive. Cotangent's positive in the same place as tan is positive. Quadrant 1 and then quadrant 3. So here's my picture. Quadrant 1, quadrant 3. Okay, I'm going to use these labels, not the original, because it's going to make my life a lot easier if I don't have to think about what's happening with the side length of 3. The adjacent is 1. That's these sides right here that touch the angle theta. The opposite's the radical 3. Again, these are technically negatives. The 2's would go there. And then based on all of that, last thing we have to do is decide what is that reference angle? What is theta equal? Well, across from radical 3 is 60. But oops, we should be in radians. So switch your mindset real quick. 60 degrees in radians is pi over 3. All right. So let's think about our two answers. Quadrant 1, easy. Answer's pi over 3. In quadrant 3, what do I have to do? Well, I have to take halfway around, which in radians is pi, and then add on the reference of pi over 3. So in quadrant 3, we have to do this to get my final answer. Well, to add these, you definitely need a common denominator, which is why in the last case, remember I made that 6 pi over 6? Why don't I make this 3 pi over 3? So 3 pi over 3 halfway around plus another pi over 3 is 4 pi over 3. And those are your two answers, pi over 3 and 4 pi over 3. It takes a little time to get used to that. All right, we're going to do two more. Secant theta equals negative radical 2. Going to put that over 1, make it a fraction. Secant, remember, reciprocal of cos. So we're doing hypotenuse over adjacent. And then what quadrants are we in? All right. Well, secant is going to be negative in the same quadrants where cosine is negative. That's going to be on the left side here. These are the two quadrants cos would be negative in. Okay, so there's my picture. I'm going to put the hypotenuse as the radical 2 this time. So the radical 2 goes here. And the adjacent side, remember I never labeled the negative on the hypotenuse. So I'm going to put the adjacent as -1. This is definitely a 1, 1 radical 2 case. All right, these are all special angles. So we know that the reference angle, the reference theta, is 45 degrees. But we don't want degrees. So in radians, do you remember what 45 is? I hope it's pi over 4. So we got to get a quadrant 2 answer and then a quadrant 3 answer from that. Now, when you're in quadrant 2 and 3, it's based off of knowing what halfway around is. Remember, halfway around is pi, or in this case, 4 pi over 4. So to get the quadrant 2 answer, I have to take halfway around, which is 4 pi over 4, and subtract out the reference, pi over 4, to get the answer, 3 pi over 4. That is your quadrant 2 answer. And what I just did a moment ago for quadrant 3 is I took halfway around, which is this case, is 4 pi over 4. And in quadrant 3, you add the reference angle to get a total of 5 pi over 4. So the two solutions here to when secant of theta equals negative radical 2 would be these two angles for theta. Last one real quick. How about sine theta equals 0? Oh boy. 0, do you think we're going to draw some triangles for this one and figure out that the opposite side is 0? Boy, that doesn't make sense. I've never seen a triangle with the side length 0. So just like I showed you earlier when sine theta equals 1, this is definitely a unit circle question. Why do I keep doing that, guys? Put parentheses? No, I want another star. It's a unit circle one. So remember, sine is the y value on the unit circle. So if we think about the 4 unit circle points, when is the y value 0? The y value is 0 here and here. What are the angles in those locations? That's what I'm looking for. I'm looking for an angle. Well, the angle at the start is 0, right at this point right here. Isn't it also full circle, which is 2 pi? Yeah, but remember, I don't want to include 2 pi. We're going to include one or the other, and it happens to be that we're going to include 0. So 0 pi, the pi is technically not necessary there, but I'm just reminding you we're in radians. Oh, and halfway around is pi as an answer. Even though unit circle takes a little while to get used to, typically the process goes pretty fast when you're doing some unit circle evaluating. So this was kind of a lot thrown at you today with working backwards, but I'm hoping by the end of this lesson, you're getting pretty confident with radians here. If not, I promise that there is much more practice to come. Let me know if you have any questions at all.